Many of us have used a torque wrench when installing bolts or other fasteners, but how many understand why torquing or other preloading methods are necessary? In this lesson, we will look at the need for preload and the various methods for achieving it. A bolted joint depends on the spring tension developed when the bolt is tightened. This tension holds the parts tightly together and the bolt stretches slightly. However, if the bolt is stretched past its yield point, the metal is permanently deformed and will not spring back when the bolt is loosened. Many bolted joints are designed to function properly if the bolt is loaded or stretched to around 70% of its yield strength. A bolt that is not stretched enough does not clamp tightly, but too much stretch can break the bolt or deform the threads. The technician must be certain that the specified stretch or preload is developed. Too much or too little and the joint will fail. If multiple fasteners are used, proper tensioning ensures that each bears an equal part of the load. There are several methods used to preload bolts. Four of the most common are torque measurement, angular displacement, direct tensioning, and preload indicators. Measuring the force needed to turn a nut or bolt is the basis for torque measurement. This force increases as preload increases, so torque can be used as an indicator of preload. Some of the turning force must be used to overcome friction between the head, washers, nut, and threads, and this must be accounted for when calculating torque values. These friction forces account for between 50 and 80% of the torque needed to turn the fastener. Because it can never be known exactly how much turning force is lost to friction, torque measurement is not as accurate as some other methods, but the process is relatively simple and inexpensive and widely used. Angular displacement, also known as the turn of the nut or turns method, relies on the fact that a given thread will advance a certain amount in one turn. If the thread pitch is known, the distance that a bolt will stretch for a given amount of rotation can be calculated. Bolts or nuts are run down until snug, and then rotated to a specified position. Direct tensioning uses hydraulic pressure to stretch a fastener to a specific length. Then the nut is screwed down, and the pressure is released. Because none of the applied force is lost to friction, this system produces very accurate preloading. Preload indicating washers, also called direct tension indicators, give the installer a visual or tactile indication when the correct preload is reached. These may use a rotating ring that becomes locked at a specified load, or a series of bumps on the washer face that flatten under a given clamping force. Some incorporate brightly colored silicone that squirts out of the washer when the joint is properly clamped together. These devices are accurate, but relatively expensive, and may not be reused if the bolt is loosened. No matter which method is used, always adhere to the work instructions provided by the manufacturer when installing and preloading fasteners.